Hi guys, welcome back to engineeringtalks.com. In this video, we'll go through the analysis of plane trusses using the method of joint. These are the methods used for the analysis of plane trusses. These include method of joint, method of section, method of tension coefficient, and graphical method. The first three methods are the analytical methods. Nowadays, graphical method is rarely used since computer-aided analysis has become very popular. So, happy learning, and if you haven't subscribed the channel yet, please do subscribe and press the bell icon. In this video, we'll see how we can analyze a given plane truss using the method of joint. In the previous video, I clearly explained that when external loads act on a truss, the members will be subjected to either compressive force or tensile force. Suppose a member is subjected to a compressive force like this. Then there will be an equal and opposite force induced in the member, and it can be represented by arrows going away from each other like this. So a member under compression can be represented by arrows going away from each other. And when a member is subjected to tensile force like this, then there will be an equal and opposite force induced in the member, and it can be represented by arrows coming towards each other. So, a tensile force in the member can be represented by arrows coming towards each other. Here you can see that at any joint, the forces in the members and the loads acting at that particular joint constitute a system of concurrent forces, right? So at each joint, we can form two equations of equilibrium. Therefore, for analyzing a given plane truss using the method of joint, we'll have to first find a joint where there are only two unknowns, because we can form only two equations of equilibrium at each joint. In most of the cases, such a joint with only two unknowns can be found out only after finding out the reactions at the support by considering the equilibrium of the entire frame. So after finding out the reactions of the supports, we'll have joints where there are only two unknowns and start the analysis. This equation m equal to 2j minus 3, where m is the number of members and j is the number of joints, is the equation for a perfect frame or a determinate frame. You can watch the previous video in order to understand the different types of frames. I'll provide the link in the description. In this case, we cannot find a joint where there are only two unknowns. So what do we have to do? We have to consider the equilibrium of the entire frame. So let's first find out the moment about this joint A. Summation MA will be equal to 0. Let all the anti-clockwise moments be negative and clockwise moments be positive. This reaction force RD has a tendency to produce an anti-clockwise moment with respect to this joint A. While these loads 40 kN, 50 kN and 60 kN have tendencies to produce clockwise moments with respect to this joint A. We know that moment is equal to force into perpendicular distance. Perpendicular distance between RD and joint A is 4 meters. Perpendicular distance between 50 kN and joint A is 2 plus 1, which is equal to 3 meters. Perpendicular distance between this joint A and 40 kN is 1 meters, while the perpendicular distance between 60 kN and joint A is 2 meters. Therefore, moment about A due to RD and these loads will be equal to minus RD into 4 plus 60 into 2 plus 50 into 3 plus 40 into 1 is equal to 0. Therefore, RD will be equal to 60 into 2 plus 50 into 3 plus 40 into 1 by 4, which is equal to 77.5 kilonewton. Let us now consider the equilibrium of the forces. So summation FH will be equal to 0. Here you can see that there are no horizontal forces in any of the joints. So the horizontal reaction at joint A due to hinge support will be equal to 0. That is, HA will be equal to 0. Now summation FV will be equal to 0. So RA plus RD minus 60 minus 40 minus 50 will be equal to 0. Here we have considered all the upward forces as positive and downward forces as negative. Now from this equation we can get the value of Ra. So Ra will be equal to 40 plus 50 plus 60 minus Rt, which is equal to 72.5 kilonewton. Now we have two joints, joint A and joint D, with just two unknowns. So we can start analyzing this truss from joint A or joint D. Let's start from joint A. At joint A, we have a reaction force Ra and two unknown forces FAB and FAE from the members AB and AE. Let's initially assume the directions of FAB and FAE as going away from the joint like this. Before considering the equilibrium of the forces at the joint A, we'll have to resolve this force FAB into its horizontal and vertical components. Horizontal component of FAB will be FAB cos 60, whereas the vertical component of FAB will be FAB sin 60. Now we can consider the equilibrium of the forces. So summation FV equal to 0 implies FAB sin 60 plus RA is equal to 0. Both are positive because both are acting in the upward direction. Now FAB will be equal to minus RA by sin 60, right? RA is equal to 72.5. So this will be equal to minus 72.5 by sin 60, which is equal to minus 83.72 kilonewton. Since this is negative, we'll have to reverse the direction of FAB as towards the joint. You can see that this force FAB is acting in the downward direction and towards the left side. So when we resolve this force AB into its horizontal and vertical components, its horizontal component FAB cos 60 will act in the left direction, while its vertical component FAB sin 60 will act in the downward direction. Let any force acting in the left direction be considered as negative and any force acting in the right direction be considered as positive. Therefore, when we consider the equilibrium of the horizontal forces, FAE will be positive while FAB cos 60 will be negative. So, FAE minus FAB cos 60 is equal to 0. Therefore, FAE will be equal to FAB cos 60, which is equal to 83.72 cos 60 because FAB is 83.72 kilonewton. Now this will be equal to 41.86 kilonewton. Therefore, FAE is equal to 41.86 kilonewton. This value is positive. Therefore, the force FAE is acting away from the joint A and it can be represented like this. There will be an equal and opposite force from the joint E and it can be represented like this. Now you can see that the force induced in the member AE is represented by arrows coming towards each other, which means that the member AE is under tension. Therefore, the force FAE will be tensile. Direction of the force FAB is towards joint A, right? Like this. Now there will be an equal and opposite force towards joint B and it can be represented like this. Now you can see that the force induced in the member AB is represented by arrows going away from each other, which means that the member AB is under compression. Therefore, the force FAB is compressive. Let's now analyze the joint D. At joint D, we have a reaction force RD and two forces FDE and FDC from the members DE and DC. Let's initially assume the directions of FDE and FDC as going away from the joint like this. Before considering the equilibrium of the forces at the joint D, we will have to resolve this force FDC into its horizontal and vertical components. So the horizontal component will be FDC cos 60 and it will be acting in the left direction. And the vertical component is FDC sin 60 acting in the upward direction. Let's now consider the equilibrium of the forces. So summation FV is equal to 0 implies FDC sin 60 plus RD is equal to 0. So FDC will be equal to minus RD by sin 60. RD is equal to 77.5 kilonewton. Therefore, this will be equal to minus 77.5 by sin 60, which is equal to minus 89.5 kilonewton. Since this is negative, we will have to reverse the direction of FDC. So FDC will be acting towards the joint. Now when we resolve this force FDC into its horizontal and vertical components, its horizontal component will be FDC cos 60 acting in the right direction, whereas the vertical component FDC sin 60 will be acting in the downward direction. Now let's consider the equilibrium of the horizontal forces. So summation FH will be equal to 0. Implies that minus FDE plus FDC cos 60 is equal to 0. So FDE will be equal to FDC cos 60. But FDC is equal to 89.5 kilonewton. So 89.5 cos 60 will be equal to 44.75 kilonewton. This value is positive, which means that we do not have to reverse the direction of FDE. So FDE will be acting away from the joints D and E like this. Therefore, the force induced in the member DE is represented by arrows coming towards each other, which means that DE is under tension. Now, this force FDE is towards the joint D. So, the force FDE will be acting towards the joints D and C. The force induced in the member DC is represented by arrows going away from each other. So, the member CD is under compression. Therefore, the force FDC is compressive and force FDE is tensile. Let's now analyze the joint B. At this joint, we have a load 40 kilonewton and forces FAB, FBE and FBC from the members AB, BE and BC. We have already found out the value of FAB when we analyzed the joint A and its direction is towards the joint. So FAB will be acting towards the joint like this. Now we have only two unknowns FBE and FBC. Let's assume the directions of FBE and FBC as going away from the joint like this. Before applying the equilibrium of forces at this joint B, we will have to resolve the forces FBE and FAB into their horizontal and vertical components like this. So the horizontal component of FAB will be FAB cos 60 rightwards and the vertical component will be FAB sin 60 in the upward direction. Whereas the horizontal component of FBE will be FBE cos 60 rightwards and the vertical component of FBE will be FBE sin 60 downwards. Now summation FB equal to 0 implies FAB sin 60 minus 40 minus FBE sin 60 is equal to 0. Therefore, FBE will be equal to FAB sin 60 minus 40 by sin 60. We know that FAB is equal to 83.72. Therefore, 83.72 sin 60 minus 40 by sin 60 is equal to 37.53. This is positive. So, we do not have to reverse the direction of FBE. So, the direction of FBE will be away from the joints. Now, summation FH is equal to 0 implies FAB cos 60 plus FBE cos 60 plus FBC is equal to 0. Now, FBC will be equal to minus FAB cos 60 minus FBE cos 60, which is equal to minus 83.72 cos 60 minus 37.53 cos 60, which is equal to minus 60.62 kilonewton. Since this is negative, we will have to reverse the direction of FBC. So it will be towards the joint like this. The direction of this force FBC is towards the joint B. So there will be an equal and opposite force towards the joint C. Therefore, the force induced in the member FBC can be represented by two arrows going away from each other, which means that the member BC is under compression and the force FBC is compressive. This force FBE is going away from the joint B. Therefore, there will be an equal and opposite force going away from the joint E and it can be represented like this. Therefore, the force induced in the member BE can be represented by arrows coming towards each other, which means that the member BE is under tension and the force FBE is tensile. Let's analyze the joint C. At this joint, we have a load 50 kN and forces FBC, FCE and FDC from the members BC, CE and DC respectively. We already know the values of FBC and FDC, and both FBC as well as FDC are acting towards the joint C. The only unknown here is FCE, and let's assume its direction to be going away from the joint C like this. Before considering the equilibrium of the forces at this joint C, we'll have to resolve the forces FDC and FCE into their horizontal and vertical components. Since here we have only one unknown, we only need to consider either the equilibrium of vertical forces or equilibrium of horizontal forces. Let's consider the equilibrium of vertical forces. So summation FV will be equal to 0. So the vertical component of FCE will be FCE sine 60 and it will be acting in the downward direction, whereas the vertical component of FDC will be FDC sine 60 and it will be acting in the upward direction. Therefore, summation FV will be equal to FDC sine 60 minus FCE sine 60 minus 50 is equal to 0. Therefore, FCE is equal to FDC sine 60 minus 50 by sine 60, which is equal to 89.5 sine 60 minus 50 by sine 60, because FDC is equal to 89.5. This is equal to 31.76 kilonewton. So the force FCE will be going away from the joint C like this, as a result of which another equal and opposite force will be going away from the joint E like this. Therefore, the force induced in the member CE can be represented by arrows coming towards each other, which means that the member CE is under tension and the force CE is tensile. Finally, you can make a table like this consisting of the members present and the magnitude and nature of the force present in each of the members. Please do like and share the video and subscribe the channel. Thank you.